Have you ever wondered what happens when scientists release something so deadly that it literally kills snakes from the inside out? Well, Florida just did exactly that, and what happened next will blow your mind. We're talking about a biological weapon so precise, so devastating, that it's changing the entire ecosystem of the Everglades. And the results? They're beyond anything scientists expected. Picture this. You're walking through the Florida Everglades, and suddenly you see a massive Burmese python writhing in agony, its body convulsing as something invisible tears it apart from within. This isn't science fiction. This is happening right now in Florida, and it's all part of a desperate plan that's either going to save an entire ecosystem or create an ecological disaster of unprecedented proportions. The story begins with what many consider the worst environmental catastrophe in modern American history. The Florida Everglades, once a pristine wilderness teeming with native wildlife, had become a battleground. But this wasn't a war between humans and nature. This was nature against an invader so successful, so adaptable, that it threatened to destroy everything in its path. Burmese pythons, these massive constrictors native to Southeast Asia, had somehow established themselves in the Everglades. How did they get there? The answer is both simple and infuriating. Irresponsible pet owners, faced with snakes that grew far larger than expected, simply released them into the wild. What started as a few abandoned pets quickly became an army of apex predators with no natural enemies. These pythons aren't just big, they're massive. We're talking about snakes that can grow over 20 feet long and weigh more than 200 pounds. Imagine encountering one of these monsters in the wild. They're incredibly strong, capable of crushing the bones of their prey with ease, and they have an appetite that seems limitless. But here's where the story gets truly terrifying. These pythons began reproducing at an alarming rate. A single female can lay up to 100 eggs at a time, and in the perfect environment of the Everglades, with its year-round warmth and abundant prey, they thrived like nothing scientists had ever seen before. The impact on native wildlife was catastrophic. Studies revealed that in areas heavily populated by pythons, mammal populations had declined by a staggering 90%. Raccoons, opossums, rabbits, even deer and alligators were disappearing. These pythons were literally eating their way through the entire food chain, leaving behind an ecological wasteland. Wildlife officials tried everything. They organized hunting expeditions, offering bounties for dead pythons. They used tracking dogs, thermal imaging, even trained hunters from other states. But for every python they killed, dozens more remained hidden in the vast wilderness of the Everglades. The situation seemed hopeless. Traditional methods weren't just failing, they were barely making a dent. Pythons are masters of camouflage, spending most of their time hidden underwater or buried in vegetation. They're nocturnal hunters, making them nearly impossible to track during the day. And their reproductive rate meant that even successful hunting efforts couldn't keep pace with their population growth. That's when Florida wildlife officials made a decision that would change everything. If they couldn't kill these pythons from the outside, maybe they could kill them from the inside. They turned to biological warfare, specifically targeting these invasive predators with something that would hunt them as relentlessly as they hunted native wildlife. Enter the parasitic nematode, a microscopic worm that would become the python's worst nightmare. But this wasn't just any parasite. Scientists had discovered a species of nematode that specifically targets pythons and other large snakes. These tiny creatures, invisible to the naked eye, had evolved over millions of years to be the perfect python killers. Here's how these biological weapons work, and it's both fascinating and horrifying. The nematodes enter the python's body through various openings, including the mouth, nose, or even through the skin. Once inside, they begin to multiply rapidly, spreading throughout the snake's internal organs like a living plague. The nematodes attack the python's respiratory system first, making it increasingly difficult for the massive snake to breathe. Then they target the digestive system, preventing the python from properly processing food. As the infestation progresses, the nematodes begin attacking the nervous system, causing the python to lose coordination and eventually become completely paralyzed. But the most devastating effect is what happens to the python's reproductive system. The nematodes specifically target the reproductive organs, ensuring that infected pythons cannot breed. This means that not only are existing pythons dying from the inside out, but their ability to create the next generation is completely destroyed. The death process is slow and agonizing for the pythons. Unlike a quick kill from a hunter's bullet or trap, the nematode infestation can take weeks or even months to fully kill a large python. During this time, the snake becomes increasingly weak and disoriented, making it easier for researchers to track and study the effectiveness of this biological warfare. Florida wildlife officials began releasing these nematodes into known python habitats in a carefully controlled manner. They didn't just dump them randomly into the ecosystem. Instead, they used a precise delivery system, targeting specific areas where python populations were densest. The goal was to create infection hotspots that would spread naturally through the python population. The initial results were promising but limited. Researchers began finding dead and dying pythons with clear signs of nematode infestation. But would this biological weapon be effective enough to actually control the massive python population? The answer would take time to emerge. As months passed, something remarkable began happening. Python sightings in treated areas started declining dramatically. But more importantly, researchers began documenting something they hadn't seen in years. Native wildlife populations were beginning to recover. Small mammals that had virtually disappeared from certain areas started reappearing. Bird populations that had been decimated began showing signs of growth. The nematodes were spreading through the python population faster than scientists had anticipated. Pythons, being cannibalistic, were actually accelerating the spread of the parasites by eating infected members of their own species. It was like watching a biological chain reaction unfold in real time. But then something unexpected happened, something that no one had predicted. The nematodes didn't just stay contained to the python population. They began affecting other snake species as well. Native snakes, including some that were already endangered, started showing signs of nematode infestation. This created a massive ethical and ecological dilemma. The biological weapon that was successfully killing invasive pythons was now threatening native species that Florida was trying to protect. Scientists found themselves in an impossible situation. Do they continue the program and risk losing native snake species? Or do they stop and watch the pythons continue destroying the entire ecosystem? The controversy exploded across scientific communities and environmental groups. Some argued that the collateral damage to native species was an acceptable price to pay for saving the overall ecosystem. Others claimed that introducing any biological weapon into a natural environment was playing with fire and would inevitably lead to unintended consequences. Emergency meetings were called. Wildlife officials had to make a decision that would affect the future of the Everglades ecosystem. They decided to continue the program, but with much more careful monitoring and targeted application. They developed new techniques to deliver the nematodes more precisely, focusing on areas with the highest python concentrations and lowest native snake populations. The results over the following year were both encouraging and troubling. Python populations in treated areas continued to decline significantly. Some areas that had been completely overrun by pythons were now showing python population decreases of over 70%. The recovery of native wildlife accelerated, with some species returning to areas they hadn't been seen in for over a decade. However, the impact on native snakes remained a serious concern. Several species showed population declines, though not as severe as initially feared. Scientists realized they were witnessing evolution in action, as some native species began developing resistance to the nematodes, while others remained vulnerable. Today, the program continues with careful monitoring and constant adjustments. Scientists are developing new strains of nematodes that are even more specific to Burmese pythons, hoping to reduce the impact on native species while maintaining effectiveness against the invasive population. The long-term implications of this biological warfare approach extend far beyond Florida. Other states and countries dealing with invasive species are watching closely, considering whether similar biological weapons could solve their own ecological crises. The success and challenges of Florida's program are providing crucial data for future conservation efforts worldwide. What's happening in the Everglades right now represents a new frontier in conservation biology. We're witnessing the first large-scale use of biological weapons against an invasive species, and the results are reshaping our understanding of ecosystem management. The pythons that once seemed unstoppable are finally meeting their match, but at a cost that scientists are still calculating. This story is far from over. As python populations continue to decline and native wildlife recovers, researchers are documenting every change, every success, and every unintended consequence. What they're learning will influence conservation strategies for generations to come, proving that sometimes the most effective solutions come from the smallest warriors fighting battles we can't even see.